must be added to the cost of the food. Express the total cost for the party as a function of the number of people attending, and then so on. So that's part A, we'll call it there. So if I don't know what your major is, but this is kind of like a business problem. It's got a fixed plus a variable cost. So it's $120 no matter what, just to get started. And it's $11.95 per person. They don't tell you what variable to use, so we'll just use X for the per person part. Okay. But then it says a 17% tip must be added to the cost of the food. So we assume that the 11.95 is the cost of the food, and the flat fee does not contribute toward that at all. So you got to be careful here though. So if you multiply by 0.17, that just gives you the tip. But if you multiply by 1.17, that gives you the new amount that's due. So my point here is it's not times 0.17, it's times 1.17, because then it includes the original cost and the tip. Is that okay? Is that clear?
Yeah.
All right, now it says it wants it as a function, okay, function. So you got to pick a letter like C of X, for cost, something like that. And then you probably want to simplify here since this is being turned in. It's good to label your variable. X is the number of people attending. Something like this. All right. And then we do want to multiply the 11.95 times 1.17. So I'll do that now, 11.95 times 1.17. And you get kind of a, bad fraction, or decimal, but that's just the nature of these things. All right, so there's your cost function. That's part A. We'll call it. Part B is to graph this in the appropriate window, labeling axes and scale. Now I'm sure you've heard of Desmos before.
Yeah.
Okay, so I'm going to go right there. I'm going to new share that screen with you, and we're going to graph it in there. Now you don't use functions in Desmos, you use Y. 120 plus 13.9815 X. And you could zoom out here, but the question's really asking you to find like an appropriate window. So what we don't know is how many people are going to attend, but we can make a guess. Okay, we can say, and this is our x-axis, we can make a guess that there's going to be, I don't know, 100 people that might attend. Okay, now our y-axis is the cost, just kind of estimating. You've got that initial cost of 120. Let's just throw up $1,000 as your kind of your top end here, but it really depends on how many people are going to attend. But if you look a little closer at the problem, it says if the budget for the party is $17.45, okay, that tells you that our y-axis isn't quite high enough. We probably had to go up to like something like 2,000, for example. And we might even want to graph the budget line right there. So notice I can't see it on the X. So I'm gonna have to go out a little bit further. I'm gonna go back to the default here. So we're gonna go 0 to, I don't know, we'll say 150, and then 0 to 2,000. And we might have it in this window. Looks like we do. Okay. So let me snip this into the other screen, and then we'll talk about how to actually label this. If you've used Desmos before, it's pretty nice because it really makes it easy to figure out what's going on here. So let me go back to the other screen. The graph's always a little too big when it comes in first. All right, so here's the graph here. So on the x-axis, you want to probably label that it's the number of people attending, and on the y-axis is the cost in dollars, like that. Okay, and that is probably enough. Let's go back and actually look at what the question says. It says graph this function in an appropriate window, labeling the axis and scale. If the budget for the party is $17.45, how many people can attend? So that's part C. So really two approaches for part C. One approach is to look at the graph like we have here and figure out, well, where did the two lines intersect? And you can see it's at 116.225 people. You probably know that you can't have a partial person. So you
Yeah.
would typically round down to 116. Okay. If you wanted to do it by hand, you would have to set the equation above this cost function right here. We'll do that below. I don't know if you need to do that or not, but you would set this equal to 1745, and you would solve it using, appropriate methods here. Subtract 120 from both sides, which is 1625 equals 13.9815x, and then dividing both sides by 13.9815 to get your final answer. We should get the same result. You should get it's 116 people.
Yeah.
Okay, so it says explanation should be given in a complete sentence. Have you already turned one of these in before and gotten feedback?
I haven't
Like
gotten feedback from my last assignment. No.
okay, not are they using Gradescope still for
They're
these?
using Gradescope, yeah.
Yeah, so you want to, check that, because you may find like you did it right, but you didn't do it the way they want, meaning like you didn't use a full sentence, you didn't put a period at the end. And I mean, college is very different. They're like, they want it a certain way. If you don't do it a certain way, you're out. You're gonna, meaning like they're not gonna like ask you to fix it. They're gonna say, do it better next time.
Yeah.
Unfortunately. Okay. Should we move on to question 2?
Yeah, sure.
All right. Have you tried this one on your own?
Yes.
Okay. I'm going to read it so I can catch up. According to the U.S. Census Bureau, the population in Arizona in the year 2000 was 5 million and a bunch of people. In the year 2010, it was 6 million and a bunch of people. The population was growing at an approximately constant rate during this period. So that's really important here. Constant rate. What does that mean? Anything to you?
So it's like the same change every time, right?
Rate can mean a lot of things. We usually think of it as a percentage rate is really what they're talking about when they usually are referring to a percent change each time. So like a linear model would have the same increase, and that's really what you're doing here. You're working on linear versus exponential models in this part of the course. Does that sound right? Or well, you know what? I take that back. It is saying linear functions on your homework. So maybe you are just doing, yeah, you probably are just doing linear. So forget that. That would have been bad. All right. So they want the slope. Okay. And to get the slope, you need 2 points. All right. And what you also need to know is, well, what's on your x-axis and what's on your y-axis. So the year or the time is down here. And on your y is the population. So sometimes it's good to write that it's like year, comma, population, so that when you're writing the data points, you're in the right space. So 2000, and then the 5,130,632, and then the other data point is 2010, 6,392,017, like that. Okay. Do you know your slope formula?
Yeah. Y2 minus Y1 over X2 minus X2 or X1.
Got it. You got it here. Sometimes it's good to label the points just to make sure that you remember where to put those. Do you have a calculator handy
Yeah.
with us? I'd like you to try calculating the slope, please. I'll do the same, but I got to go to the other over here and do it. All right, I've written down my slope answer. Is yours consistent with that?
Yes.
Okay. All right, so the good thing is it's positive. We know that it's trending up. Okay. Now the next thing is we have to express this model as a function of time. So that's your part A, we'll say. But they want you to use your base year as 2000. So they're saying when t equals 0, this corresponds to year 2000. You see that all over the place in this course. So the function here, f of x, you can think of it as mx plus b, the slope intercept form.
Mhm.
All right. So what you calculated is the slope. So it's going up by 126,138.5 people per year. Let me just double check. Did it specify a variable? No. We should probably use t though, because it is a time. And we might even want to say that t is the number of years since 2000. Okay. That like they're looking for that. Plus b. Now b is the y-intercept, but more generally, it's the starting value. B is the initial number of people. So that 5,130,000, that's going to be your B in this case. 5,130,632. And then I guess you can use something better than F. You could say population as a function of time, P of T.
Mhm.
Something like that. That might be more rigorous. Like the variable really doesn't matter, but that someone grading us might wonder why you chose, J instead of, T or X, but nevertheless. So that's it for part A. Part B is what would this model indicate that the population of Arizona was in the year 2005? So you got to figure out, well, what does that mean in terms of a T value? It is not 2005. It is 2005 minus 2000. You're always subtracting that base year. So you're finding P of 5. Oops, wrote that wrong. 138.5 times 5 plus the 5,130,632. Probably most of the mistakes occur just as a result of not entering this into a calculator correctly. So if this were a test or a quiz, I would probably say to do the calculation more than once and make sure that you get the same result each time.
Yeah.
So I get 5,761,324.5 people. And is that a reasonable guess? I mean, it's a little low, but it's not that far off. Census datas are not, they're good, but they're not perfect.
For what is that again? Sorry, that was the population.
Yeah, that's the population in 2005.
Yeah. Check what I got. I didn't get that.
Another kind of small point here is sometimes these questions you got to make sure you answer all parts of them. They they don't label them A, B, C, D. They just want you to know that each thing is its own part. Any questions on that before we move on to number 3?
I think I'm good on that one.
Great. Right. So a solar water heater. Okay, solar water heater costs about $5,730 to install after rebates. A traditional gas water heater costs about $900 and costs about $310 per year to run. The average annual cost to run the solar heater is about $80. Okay. So what they're trying to tell you, there's two situations here. There's the solar and then there's the gas. And they each have their own costs associated with them. It's always the fixed like the one-time cost plus the variable cost. So can you give me the equation of the cost for either the solar or the gas heater based on that first sentence, first two sentences, I guess?
The solar, that would be T 5,730. Oh, wait a minute. Hold on.
That's the fixed cost. That's true.
Yeah, so that's a 6 hours. Gas is 900 fixed costs.
Okay.
And cost 110 or 310 per year to run. So it's a variable.
All right. Let's do Y for year this time. And how about the
Oh,
fixed cost for gas?
It's flipped. For the gas, this is 310. Okay, and then solar. Okay, solar would be 80 a year.
Yes. And the idea here is that you're spending more upfront for one, but you have less cost each year. Gas is less upfront, more per year, which makes you wonder, well, why wouldn't you just do the one that's cheaper per year? Well, it's because it costs you more to start, and both systems do break eventually. I mean, these don't run into infinity. So, but for practical math problems, these are okay. So these are the cost functions of each. And if you organize your work this way, where you kind of almost got a table to it, it does help to, demonstrate understanding. All right, so now we are going to have a problem because it does say to graph here again. So I will have to change the variable again. Create a total cost functions. We've done that. Graph these functions. Okay, so we're going to go back to the Desmos here and look at the graphs. There it is. Okay, so the solar, I'm going to use I'm going to use solar is going to be 5,730 plus 80x. Okay, and you can see you cannot see the graph. It's because it's way up here. So we'll have to fix our axes in a moment. And then for the gas, it's 900 plus 310x. All right, now we got to figure out our axes. So like a reasonable time horizon might be like 20 to 30 years. Looks like it needs to be a little longer for these to intersect. Water heaters don't last 10 years on average, but that's a side point. So the cost, though, we're gonna have to go a little further up on the Y. So a couple options here. You can either go by a factor of 10 or double, typically is a good one. Looks like 10,000 is pretty good option there. So you can see that in 21 years, that's where they break even. And I'll snip that into the other screen here. I encourage you to try graphing these on your own in the future if you've not done that in a while. All right, let me go back to the other screen. So kind of a couple things to pretty this up here. We want to indicate that this is time in years. Y is the cost in dollars. And you might want to indicate that the first one is the gas and the second one is the solar. So in practical terms, and I'm going to send this to you at the end here. Practical terms, like you have to decide, well, is it going to last 21 years or not? That's a different question altogether. But part C is the answer to that. It's right there. It's 21 years. You can alternatively solve for the intersection of these two equations, which we'll do that here down here at the bottom. So you just set them equal. 5,730 plus 80y equals 900 plus 310y. Subtract 80y from both sides. Subtract 900 from both sides. and you get 4,830 equals 230y divided by 230. Apparently that equals 21 years. I don't know if you need to show all that, but that would be the show your work part if you needed.
Okay.
All right, so this a good place for us to stop here.